All right, welcome. Thank you very much for attending today's session, SAP HANA HA on AWS, Preventing Production Facepalms. My name is Brian Griffin, and I'm part of AWS's Professional Services SAP Global Specialty Practice. And with me today is Samkit Kamanavan, who is AWS SAP Partner Solution Architect. And we're here today just to have a little chat about some strategies and architectures that you can use to prevent production facepalm moments when, there we go, when running production SAP HANA landscapes. So everyone has had a facepalm moment. It's that expression of disbelief, shame, exasperation. Maybe it's because you made a mistake and accidentally shut down a production system when you meant to shut down a sandbox. Guilty. Maybe it's the face that you make when you get a phone call at 3 a.m. letting you know that critical batch job has failed because instance has fallen over. Or maybe it's the worst case scenario where you get the phone call letting you know that there's an issue in the data center and all of your SAP apps are offline. Regardless of the situation, we're here to show you some tools and techniques that you can use to avoid this particular moment. In the process, we're going to go through and we're going to compare and contrast some SAP on-premise HANA HA solutions with some of the native capabilities of HA and AWS. And we're going to define 4 different reference architectures for SAP HANA HA and how to go through and evaluate them. Lastly, we're going to share some of our insights and implementation experiences from being down in the trenches in some of some of AWS's largest SAP customers, with the goal here to go and really arm you with information so that you don't make a facepalm decision like not running HA on a multi-million-dollar HANA database. So let's just level set here. You're an SAP basis architect and it's busy season. Maybe you're like one of the retailers that is a customer of mine and you do 80% of your business between the months of November and February. Or maybe you're in the financial services industry and you have a month-end, quarter-end, year-end close. Or maybe you're part of a business that is very low margin, high volume, like a wholesale distribution. Regardless of the situation, we're all in the same situation. It's that our SAP systems are mission critical for the business. I have 4 simple steps, which were taken from a formula I saw in South Park, so you know it's good, to follow on your path to profitability. If you do these 4 steps exactly, profitability is pretty much all but ensured. So step 1, run SAP. It's a good deal. I think most of us are doing that. Step 2, make it highly available. I think probably most of us are doing that in some capacity. Step 3, step 4, profit. So we're already there. The good news here, again, is our SAP ECC systems or BW systems are absolutely mission critical. We said that before. To quote my colleague Eric Brandewine from last week's reInvent session, you have an SAP environment and it is precious. Now, let's talk about some complications that you see on premises. The first complication I see, is that we rely on a disaster recovery site instead of relying on HA. By a show of hands in the room, who is running some sort of HA in their on-prem or AWS implementation? All right, good deal. Second complication that we see is we see high availability being run in one data center. By a show of hands, who here is running HA that spans across data centers? Okay, so a little less hands. And what we would say is that, unfortunately, that type of setup, where you're not spanning across data centers, wouldn't pass our AWS well-architected review. Now, you might say, well, so what? I've implemented HA, so I can sleep soundly at night in my fortress of solitude. Well, good news is that your companies, while you're at reInvent, have planned some routine maintenance, just nice and easy routine maintenance on your fire extinguishing systems. Nothing to do with SAP. The bad news is that workers have accidentally set those fire extinguishing system alarm off. So mind you, there isn't actually a real fire that's taking place here, but the system thinks there is because, the alarms are tripped. So releases fire suppression gas, which then triggers the air conditioning to turn off so you don't feed those fake flames with additional oxygen. And it turns out that those servers actually need that air conditioning to work properly. So if you've been paying attention to the news, this exact scenario happened, and the result was a 7-hour downtime. And this is not limited to one particular situation. This stuff happens all the time. We know from the data that systems fail, and they do so at an alarming rate. What makes it worse is 88% of those failures are caused by human error or data center specific failures, like the scenario I described. So what does that mean? That means even if you're running a fancy clustered HA setup, the end result is the same, system failure. Now, what happens when a system fails, or what happens when you're in that scenario? Well, most enterprises will start down their business continuity playbook. They'll start their disaster recovery a few hours after the first downtime happens, which really implies two things. Number one, data loss. Most DR scenarios will include some level of data loss based off of your RPO, right, your recovery point objective. The second thing is longer downtime. Samkit will get into this in a few slides, but the DR RTO for time frame for enterprises is consistently somewhere between 12 and 24 hours. So it should be abundantly clear to everyone that DR scenarios should really only be used as a last resort. Right? You're using those for catastrophic outages affecting entire geographies. What you really want is your HA solution to take care of those 88% or more of those common failure scenarios, which are happening a lot more frequently. So what is the impact of downtime? Well, I'm not going to sugarcoat it. The implications of an event like that are disastrous. If your ECC system is where all of your orders and financial data are held, and I actually had something like this happen to me when I was a junior-based administrator. Customers were at my client stores around the nation, waiting in line without the capability of checking out for nearly an entire day. So those customers are in line with their prescriptions, waiting while the employees are running around getting papers, pencils, calculators, tax tables, trying to manually check these folks out. Can you imagine what a response like that would get today? How long would you wait personally before you decided just to walk out of the store with whatever it was that you had? How much financial and brand damage is going to take place in the weeks, months, or years to come? And how long do you think it's going to take before an event like this hits social media and goes viral? And also on the personal side, how much of an impact like this do you think it's going to have to the IT architects or administrators who designed and supported that solution? Do you think that the next talks are going to be about promotions and bonuses? Probably not, and that actually is probably a little unfair because after all, they co-architected this with the business who had told them a 12 to 24 hour RTO is totally fine. So AWS would posit that customers shouldn't have to be in this situation. Customers should have a choice in implementing multiple HA options depending on their very specific budget and IT cost considerations. If a customer wants to have a highly available system which can withstand an entire data center outage, they should be able to do so without breaking the bank. I urge you to do what many of your peers have already done and test out some of the capabilities that we're about to describe. There are multiple HA options on AWS, and Samkit's about to outline options you can choose from based off the downtime and cost profile.
Great. Thanks for that great introduction, Brian. Hey, my name is Samkit. I work as a SAP Solutions Architect at AWS. Work with partners and customers much like yourselves talking about HA. So, before we dive into the details, I'd like to ask the question really, what is high availability? And the question means many different things to many different people, right? So let's level set, what is availability, right? Let's start with a common understanding, and then we'll dive in and answer the question, what is high availability, right? So let's start off with a refresher, right? So what is a failure? A failure is when something is broken. Your service is down, your SAP system is down, right? What is mean time between failure, right? MTBF is a common acronym. It's average time when something is working, right? This is your uptime. And mean time to repair or mean time to recover, right? This is how long it took to fix something when it broke. How long did it take you to bring it back up, right? Why is this important, right? This is important because what we're after is availability, right? Availability, we all know, it's intuitively when a service is functioning and working as is expected, right? So that's a key component. So how do we calculate availability? We do that with those concepts we just talked about, right? MTBF divided by MTBF plus MTTR, right? So with that formula, excuse me, with that formula, we can then start to answer the question, what does it all mean? What is availability? So let's do a quick example. If we try to calculate the availability of your system for 1 year, the MTBF for 1 year is 525,600 minutes. And if you had an outage of 52 minutes in that year, right? So let's say it had 4 outages per month, 4 minutes of outage, about 52 minutes per year. Your availability, if you use the formula, would be 0.999, which comes out to 99.9% availability. And by the way, our EC2 SLA was 99.95. It is now 99.99, so 4 nines of availability. So let's re-ask the question, what is high availability then, because we know what availability is. Simply state, I would say high availability is the processes and technologies we can use to increase our availability, right? So since Brian told us and gave us the reasons why failures are inevitable, what component of this formula should we be focusing on to increase our availability, right? The only thing that we can really focus on is how fast can we recover from a failure, right? That MTTR component. So before we get into that, what kind of things are we trying to protect against? Can I, show of hands, who's ever had a data center outage? Network outage? Server outage? Storage outage? Yes, right. So we're trying to protect these things, right? These things that run our SAP systems. Hardware is going to fail. Systems are going to fail, right? Another class of errors. Who's ever had like a blue screen of death happen to them? Or a Linux kernel panic? Yeah, software has bugs. And these bugs could actually take down your systems, right? I mean, software is written by humans. Humans have bugs. I mean, software has bugs, right? So these bugs are, yeah. And then for the last category, I'd like to share a personal story, like Brian was saying with his story. When I was a Unix sysadmin, I had a ticket, right? And it said, there's nothing coming out of the printer. So, I did my investigations. Oh, LPD daemon, it looks hung. Well, let's restart the LPD daemon. Boom, stuff came out. It's printing. But when you restart the LPD daemon, everything in the queue is gone, right? So this illustrates failures are inevitable because we're all human, right? We make mistakes, unintended mistakes or whatever, right? So now, from the bigger perspective, from the bigger picture, we're focusing on SAP HANA in this session, but please be aware there's SAP ASES instance. Those are also single points of failure, web dispatcher. All those SAP instances run on your network, your servers, your storage, right? Okay, so let's do a quick review. The SAP HANA components that we've seen on premises. Excuse me. You just had a sneak preview. So, host auto failover. Who's running host auto failover today? HANA host auto failover? Awesome, awesome. So, right. With host auto failover, the way it works is you have a standby node, and that standby node, the name server process on your standby node, is monitoring your primary node. And when it detects that the primary node has failed, it will take over the HANA data, HANA log, and load that data into memory, right? Then the data is available again, right? But in your on-premises environment, what would you need to have a standby node, right? You're going to have to make sure you got a data center space, power, HVAC, cooling, everything we mentioned, right, that's needed to have it. So you have to plan for that. In AWS, we'll get into this later on, but you can have a standby node, at the, just calling an API, right? The last point about the host auto failover solution is that it's really in one data center, right? Like we talked about, well architected, it's in one data center. The second pattern that we see is HANA system replication, right? So it's very similar to host auto failover. There's a redundant system, right? Again, make sure you have redundant capacity planned for. The difference between this solution is there is redundant disks, so there's no shared disk between the two solutions, right? So you're replicating from your primary over to your standby, right? And to handle your ASCS, you might have a clustering solution as well. I'd like to point out real quick there. So you see this not running, right? So there's nothing that's not running. These are all hot resources, right? So, okay, just to share a quick example of a real live AWS customer. This is their on-premises environment. This is a Fortune 500 customer. They are running SAP BW 7.4 VPC on any database. To protect their database, they ended up using a database clustering solution. The primary database is then replicated to the standby database. And then for their ACS, they also had a clustering solution with some app servers, right? So as part of their migration into AWS, this customer reevaluated what they needed for HA, right? Is that, how can we do things differently, right? What can we do? How can we re-architect this? How could we still meet our HA requirements? So I'd like to share with you what this customer did as part of their journey, right? So what we have over here in AZA is their primary SAP HANA system with their ACS and app servers spread across multiple AZs, right? And in a standby AZ, what they did was have a standby HANA server with SAP HSR, and also they have a standby ACS system that's actually not running right now, right? So in the event that that AZ goes down, the AZ is no longer available, here's what they do to failover. First step, they do a SAP HSR takeover, right? That's done with a script. Now that standby system becomes their primary system, right? Step two, also with the script, that ASCS was standby, it becomes now their primary ASCS, right? By the way, they do have on-queue replication between the two sites. And then their app servers are up and running, so those are hot app servers, okay? So with that preface, these are the 4 reference architectures that we developed to help guide partners and customers to understand the options available for HA in AWS, right? Before we dive into these 4 architectures, I'd like to kind of share the 4 principles we use to help develop these architectures. The first principle, like we talked about, is MTTR, your mean time to repair, mean time to recover. How can we make that as low as possible, right? That was major component. Second major component is costs. How do we keep these costs as small as possible, right? And third component is keep it simple, right? KISS, right? Complexity can really introduce failure scenarios you never thought of. You know, not until you get into the wild and it's in production, you think, wow, all this complexity, maybe it does more harm than good, okay? And then lastly, the 4th principle was, what specifically are the considerations for each of these 4 architectures, right? So our goal really here is to help you kind of see which one fits your requirements the best, right? So let's dive right into it. So Amazon Auto Recovery. Who here is familiar with VMware VMHA solution? Awesome. I like to think of Auto Recovery as being very similar to that, right? So, excuse me. CloudWatch, what CloudWatch is doing is monitoring your EC2 instance, right? When it detects either hardware failure or a network failure, CloudWatch is going to react. It's going to then institute or instantiate a recovery of your instance, right? That instance is out there in AWS. It's available, and it will restart it on an available instance for you, right? If you note, this pattern here, this is a single SAP HANA scale-up server, right? This instance is not running, you don't have to pay for that instance, right? This is very similar to SAP HANA Host Auto Failover, right? You have a standby node, you bought the standby node, it's monitoring the system, right? And it takes over when there's a failure, right? Now, as I mentioned earlier, this is a single node HANA system. What if you had a scale-out system, right? Multiple worker nodes, one master node, right? In AWS, we've now just certified 50 terabytes certified with HANA, right? So using or leveraging auto recovery, you could then have auto recovery monitor your master node, your worker nodes, and then they would all in turn get restarted, right? So let's take a deeper dive and look at actually real live auto recovery alarm being fired off at a customer's site, right? So here's the first one. The status update went from OK to alarm. And then the alarm action is EC2 auto recovery is in progress, okay? And then the next one is from the dashboard, the CloudWatch monitoring dashboard, right? You can see when the alarm fired here, that's the whole duration of the alarm. And at the end of that duration, HANA is essentially back up and available again, right? So the customer told us they didn't even actually notice that HANA was down, right? For several reasons. You're all familiar with DB Reconnect, right? The SAP work process is going to try to keep talking to the database server is not there, right? But also, you know, if a customer, or sorry, if a SAP GUI user was idle, they may not even notice anything at all, right? So, okay, now to help you kind of see, does auto recovery work for you, right? So those 4 principles we talked about earlier, right? MTTR. MTTR for auto recovery can be minutes, right? Costs. The cost of a CloudWatch alarm is $1 a month, typically per instance, right? Complexity. Pretty much complexity is limited to the CloudWatch alarm being set up. If you're running our SAP HANA Quick Start, which provisions HANA systems for you, there's an option to actually say, I want auto recovery enabled. The Quick Start, which is CloudFormation, will enable that for you on your HANA instance. And then the main consideration with auto recovery is that it recovers in a single AZ, right? The next pattern we're going to talk about is called warm standby, right? So before we get into the details, I just want to tell you some considerations to understand what warm standby. The first one is it's one of the lower cost patterns. It's lower cost because the resources can be smaller, right? So you have a primary HANA system. That HANA system in the warm standby can be a smaller size system. Or in the case of an application server, that system doesn't even have to be running at all, right? You can start these systems on demand. The second consideration, failover can be either manual or automated, right? Automated, you can use a clustering solution from one of our partners like SUSE or SIOS, or you can script your own solution, right? And because there's less moving parts, it can be less complex, third item. And then the fourth consideration is you can either choose to use warm standby in a single AZ or a multi-AZ deployment. Okay, so in our primary AZA, we have our SAP HANA database here, right? Our primary and the rest of our SAP stack. You can also choose to also enable CloudWatch on your instances as well. We'd recommend that, right? On your app servers, you know, if your app server goes down, auto recovery would fail over for you, right? The other thing is, in our primary, our EC2 instance is X1E32 extra large. That's a 4 terabyte instance, okay? On our standby, here's what we have. For our standby HANA server, we have an R4 8 extra large, a 256 gigabyte instance. That's a 15 times difference in memory size between the two, right? And to enable that, we have turned HANA preload off on this configuration. Our ASES instance is standby, not running at all. And here's our application servers. So what do? We set up SAP HSR between the primary and the standby. Because this AACS instance needs your SAP mount, we can use Amazon Elastic File System for that. Elastic File System, as you may know, is a regional service, right? And then, because this is a warm standby for your AMI, for your app servers, you can choose to use AMI snapshots to take snapshots, golden copies of your application server images. Because AMI snapshots are actually regional, as soon as you take that snapshot, it's available in the other AZ. So how would we fail over in the warm standby architecture, right? So your AZ goes away. First step that we do is resize that instance from the R4 8 extra large to the X1E 32 extra large. Resizing can be done with the API call, right? AWS EC2 modify instance attribute, right? Modify instance attribute, and then you can change it. Once you do that, you start up the instance. And then the second step, after the instance is started up, then you do the SAP HSR takeover on that instance, right? And then the second step is then you start your AACS instance, and then you start your PaaS and your AAS instances, right? And then because you're in a different availability zone with different IP addresses, you can do DNS updates, okay? So would a standby work for you in your scenario and your requirements, right? Uptime, MTTR honestly could be minutes, or could be longer, depending if you had a manual failover or automated failover. Cost, again, like we mentioned earlier, this is the most cost-optimized solution. Complexity, you can use third-party clustering, or you can roll your own. If you're interested, see me later. We have some scripts that we can share. And then the major consideration with this pattern is, like we talked about, HSR takeover, and then manually starting up your SAP instances. With that, I'm going to hand it back over to Brian to talk about the rest of the patterns. Thank you.
Thanks, Samkit. All right, third pattern is the single AZ high availability. The next pattern after this will be a multi-AZ one, but just taking a look at single AZ, very self-explanatory. All the components are in one AZ. And you might ask, why would we do that? And we've seen this out in the field for a few reasons. Number one, if you need to run synchronous replication, RPO equal to 0, and you have a database that has a very, very high change rate, then maybe a single AZ solution works best for you because of the low latency from within that particular data center or particular region, or sorry, particular availability zone. Also in a single AZ, if you wanted to keep the same IP address without having what we call an overlay IP address, you can do that by detaching and reattaching an ENI, Elastic Network Interface. And what you do there is you end up swinging it from one side over to the other, one EC2 instance over to another EC2 instance, and that effectively acts as your virtual IP address, your VIP. And then lastly, the single AZ is less complex than a multi-AZ solution, so your complexity is a little bit lower. So on top of the other solutions that we've seen before, you can also additionally toss on EC2 auto recovery for your app servers. So you can combine a lot of these different solutions, and there actually are solutions that fall in between these particular 4 patterns. There's kind of a mixture of them. So just like a multi-AZ solution we'll talk about, there's third-party clustering or your own clustering solutions you can use to do this. And then standby ASCS server, you can utilize that same clustering option. What does it look like? Well, when your particular EC2 instances fail, maybe that happens because an EBS volume goes down. That happens, I think, at a rate of three times out of 1,000. So our drives do fail. They're a lot more resilient than most places in the industry average, but plan for failure. If that happens, not a big deal. EC2 auto recovery takes up and your app servers are up and running. On the database side, your cluster swings your ENI from one instance to another, and you have that same instance size over on the other side with HSR takeover. And then you start your ASCS instance up, and that goes and eats the lock table, attaches the NQ to it, so you actually haven't lost any locks. And that's the most important thing here, because I think when a lot of people think of running high availability, they think of not losing any NQ locks. So does a single AZ solution work for you? Well, take a look at the uptime, the MTTR of minutes. Cost here is medium, we would say, because you do have that additional hot SAP HANA resource that is running full time. Complexity is also medium because requires third-party clustering or for you to create your own cluster solution, which can be complex depending on your in-house development. And then the consideration here is, like we mentioned in the start of the talk, this is in the same AZ, so it's not following a well-architected review. Maybe that's not important to you. Maybe you have other costs, or maybe you have other things that are higher priority, but certainly is an option that we've seen out in the field. And then the last piece, right, the Ferrari solution. This is the multi-AZ HA solution. So what are the advantages of running a multi-HA solution? Number one, hot standby. Over here, running an entirely separate AZ, so absolutely guaranteed to be in a separate data center. This gives you redundancy and failover at the highest levels. Similar to that detachable ENI concept that we were talking about earlier, this is actually called an overlay IP address. And in our multi-AZ solution, it allows you to update your VPC's route table to a particular IP address on a specific EC2 instance. And this EC2 instance can also live in either AZ here. And this, in essence, becomes your floating IP address, your VIP. So the last piece is that because it's multi-AZ in nature, it's protecting against a larger number of data center failure scenarios. By the way, this all can be an automated solution. We have our third-party providers that are all certified. So we have SUSE, we have Sios, we have NEC Express clusters, and then we know of at least one other partner that's in the pipe of getting their solution certified. And this is all for folks who need and want that absolute certification from SAP and from a HA-provided vendor. That's not to say that if you have your own in-house development talent, you can't go through and optimize these additional clustering solutions. These solutions are very, very slick. They take care of a lot of human error that happens in clustering, and they're also extensible. So you can add in additional steps if you have certain things that need to happen in your runbook as part of an HA solution. So maybe you need to send out additional alerts, or maybe you need to go through and check an interface file. Whatever the situation is, you can add on to these solutions. And just like the other solutions, third-party clustering, whenever this goes down, this primary goes down, third-party clustering detects the failure. That's the first piece. It goes through, it changes this standby server over here into the primary server. It changes the standby ASCS into the primary ASCS, and your SAP apps start working. What we've seen out in the field, for to give you a general timeline or time frame, longest that I was at under a Fortune 20 customer, that was about 4 minutes. That was the highest amount of failover time. Some of it depends on the particular failover scenario. Maybe it's you decided to kill the EC2 instance, or maybe decided to cause a kernel panic, whatever. There's obviously a lot of different scenarios you can do to bring an instance down, but 4 minutes was the longest time period that we saw. So does multi-AZ work for you? Well, very, very low MTTR, as we were talking about. This is the highest expense. You are running hot resources redundantly. You also are paying for a clustered solution, most likely. And the complexity is on the high side. To have all of those neat whiz-bang features, which are very, very high level, and they've been around for years and years, also comes with the risk that you may not fully understand how to use those properly. So we'll say this a little later, but running a clustered solution is not for the faint of heart. It's something that you need to make sure you understand that cluster so you don't cause yourself some false positives, which bring the system down. And considerations that, yeah, it does support multi-AZ scenarios, and then we were talking about the complexity with running a cluster. So these are just the 4 options as a recap that we discussed. You'll notice on if you can't see on the x-axis here, it's the lowest amount of uptime to the highest amount of uptime. And on the y-axis, we have the different types of failure scenarios covered. So I think we said earlier in the talk we were going to give you some lessons learned from being in the field using these solutions. First thing for auto recovery, lessons learned. Number 1 is use the AWS Quick Start. It's out there for partners and for customers to use. Go ahead and turn on that EC2 auto recovery. It's a 1 toggle button. There are so many customers that I go to that they intend to turn it on later on because it's very easy to do, but they just forget. Or they think they have turned it on and they realize that they missed it in their QA system. So just do it from the get-go. It's $1 a month per server, usually well worth that. The next piece is for that, make sure you're using it at your application servers as well. I think folks usually think about it just for databases for whatever reason, but use it for your app servers is actually a better use case. And really, most importantly, is test this. This is not something you can test on your own, by the way. This is something that you have to utilize AWS Business Support or AWS Enterprise Support. So if you have Enterprise Support, you can do this with your technical account manager. And why do you want to test it? Well, the time frame, you want to understand how long it's taking for EC2 auto recovery to actually fail over. Our use cases, what we've seen is about 7 minutes at my customers that I've been at. So that's considerably faster than it would take to pick up the phone and call a technician to come out and give you a new motherboard or whatever hardware failure it would take, hardware failure you experience on-prem. Also, there are certain OS settings that you want to make sure are set. So you want to make sure your SAP systems are set to auto start, or you want to make sure a OS setting that's preventing some sort of start of the operating system coming up. And then lastly, you want to make sure that this plays nice with your cluster configuration. Cluster configurations have a very orchestrated workflow, which is great, which is why it makes it so it takes out a lot of the human error. But you want to make sure that cluster configuration knows what's happening when EC2 auto recovery is turned on. And pro tip, if you are using EC2 ephemeral storage, most people aren't, but occasionally we'll see folks using that as like swap space or some sort of scratch space. If they've configured their ephemeral storage, it actually impacts the capability of using EC2 auto recovery. So if you're using that scenario, don't use those in conjunction. Warm standby lessons learned. This is a big one. So we talked about the capability of having a server that's 15 times larger. What does that mean for my disk space? It actually means you do need to have exactly the same amount of disk space. And this shouldn't be a big surprise to folks who are running what SAP calls their cost optimized setting on premises, because you're already kind of doing this. The thing is with the cost optimized setup, let me go back a little bit. You're usually doing this because you're usually using your cost optimized setup on a dev or QA system, but in AWS you don't have to make that distinction, and I'll talk about that why. If you're trying to figure out how big or small you can make that standby instance, it's driven by the row store and or loaded column data tables in the primary HANA database. To specifically calculate it, take a look at this SAP doc. It'll show you how to calculate the standby HANA size. And as Samkit mentioned, customer systems that we see are consistently right around 15 times smaller than their source HANA system. And because of the power of AWS and the way we price things, since most of our pricing is linear, that's a 15 times cost reduction than running a hot node. By the way, also gives you the capability of running HA in your QA environments, which I also strongly suggest. You'd be shocked at the number of customers that I go to and they have HA set up in production, which is great, until you need to start understanding how to go through and patch your clustered solutions, or you want to go through and test your clustered solutions, and then you realize you don't have something like that set up in QA. Well, in AWS, you don't have to make that distinction, because that standby instance, you can actually just shut it off. You can configure the cluster so that instance is shut off, and when you bring it online, the cluster will recognize that it's there, and then you're good to go. So you can do your testing in non-prod instead of you doing your testing in prod. And then lastly, also a remnant, and this is what we were talking about a little earlier, in your cost optimized setup on-premise, you're constantly seeing dev or QA systems being used for your disaster recovery. But what you want here is to stand up a separate EC2 instance for that. So on-prem or using dev or QA, you have the unfortunate incident of actually having to use your disaster recovery system. Well, then you have to rub a little salt in the wound because you've also just lost your dev or QA system, and it's down until either you fix the issue or your data center is fixed. So you don't have to make that distinction in AWS. Just stand up a smaller EC2 instance. Don't co-locate it with an existing dev or QA system. Oops. Yep, single AZ lessons learned. By and large, most customers will have to go through and provide their own custom scripting for this solution. There is a partner that's in the pipe that has a single AZ solution. We also have some individual scripts that you can utilize for your existing supported third-party solution, but it doesn't have certification yet from SAP. So all based off of your own particular risk appetite. We talked about this earlier, but lower levels of HANA DB latency. Useful for customers that are using HANA HSR in synchronous mode and very high change rates. For folks who don't need synchronous mode, you'll see this in our next one, our multi-AZ. But multi-AZ, you can still run synchronous, but what I see a lot of customers of mine using is the sync mem option for HANA, and that supports the performance throughput that they need and meets their RPO. And lastly, single AZ. It does not qualify for the EC2 SLAs because it is not well architected. Lastly, the single AZ solution from a networking perspective is going to be between 1 to 5% cheaper, probably closer to 1%, but up to 5% cheaper than a multi-AZ solution because of the cost of data transit between the inter-AZ data transfer costs. Multi-AZ lessons learned. The use of an overlay IP is a requirement. We talked about this earlier. What does that really mean? Well, an overlay IP is actually used outside of the CIDR block of the VPC that you're currently in. That means you also must disable the source destination check on the EC2 instance in the cluster. And in order for on-prem customers to actually reach the instances into AWS, you need to use this overlay IP address. And the reason why is if you don't, then when you go over the direct connect or over a VPN, which all of you should be doing, accessing SAP systems, it's going to reach the VGW and it's going to terminate because it can't find the IP address it was looking for inside the CIDR block. So how do we get around that? Well, we pass that through an NLB or an ELB or through Amazon Route 53, and that takes care of that particular requirement. And we talked about this earlier. Running a cluster is not for the faint of heart. Cluster setup can be verbose. Cluster costs are somewhere in the range of $1,300 to $6,500 per node. So if you have a lot of nodes or a lot of instances, then that may be important to you. Traditionally, HANA has a fairly significant cost as well. So it's all based off of your risk appetite and how many users are logging through your system. And there can be false positives. If you don't set up the cluster correctly or you make it a little too, or you don't make it fault tolerant enough, if you try to tighten up your parameters a little too much, you can have false positives and both nodes can shoot one another, bringing both sides down. Lastly, if you have concerns about running HA, by all means, reach out to Professional Services. That's the organization I work for. Just a quick plug. So we do this stuff all the time. It will expedite and safeguard your particular HA setup. It's something that takes us between 1 and 3 weeks, depending on how many systems we have to go through and set it up at. So don't let the fact that you haven't ever run a cluster solution prevent you from doing something if that meets your objectives and also your downtime risk. And with that, thank you very much. Really appreciate your time today. Love to take some questions if you have any. If you could just talk to the mic. Yep. You can just say it and I can probably, yep.
Do any of these scenarios change if you're talking about like NLS or dynamic tiering or anything like that?
So the question was, do any of these scenarios change if you're talking about NLS or dynamic tiering? Right now, NLS and dynamic tiering aren't supported on AWS, but from an actual IP move, I don't believe so. So the mechanics should all still be the same. I'll have to get back to you. We can talk offline, but at the moment, those aren't certified. When they are certified, we'll have a definitive viewpoint on that. Any other questions? Yep. Yep. So the question was on active scenarios. So right now, currently, SAP HANA doesn't have active scenarios. They will. HANA 2.0, SP3 maybe? Actually, HANA 2.0, SP3, I think. And for those situations, I know the clustering partners are going through and validating, but ultimately, I think what you're going to need is you might need a second overlay IP address. We're going to need to take a look at that to see how the end user traffic, how it's passed from the HANA system. If it's still going through the primary node, then you might not have to do anything in particular. But it's a very good question. Well, we'll see if we can answer that afterwards. Is it up? Is it up now? Okay. So there is some industry information that may have been disseminated there. I did not say that, but next. Is it? Okay. So the statement is that active is already available. I know it's coming with HANA SP2. I don't know if it's certified for all solutions, but yeah, absolutely. So for folks who aren't aware, HANA SP2 allows the capability so you can push read traffic to that second node. So it's not just sitting there as a standby node. You can actually utilize that standby instance. Yes, read only, exactly. Yep. In the back? Sure. The question is, what's the most common pattern that we've seen across clients? For me, since I'm professional services and we're constantly dealing with Fortune 500 companies, but more often than not Fortune 100 companies, they have the highest uptime scenarios. So that almost always is the last one we just gave, the multi-HA scenario. It's usually a very big surprise to them to run HA across data centers, and it's met with a healthy bit of skepticism of what's that latency going to be like. I'm not really sure if that's going to meet our requirements. So far, I have not been at a customer that it hasn't met their requirements. Again, we usually go with the sync mem option for more reasons, more from an SAP standpoint than an AWS particular standpoint, because they didn't want their secondary database, if their secondary database were to go down, they didn't want that to impact their primary. So if you run full sync, that actually does happen. Where if you run sync mem, you can set a parameter so that it recognizes the second one's down and it continues taking traffic on the primary. So yeah, by far the last pattern. But for folks who don't run SAP HA whatsoever, that first pattern is a great option, because it at least takes care of having someone go through and call a technician and have them come out. Because I've been in that situation before where I've lost a memory card or lost a network device, a network interface card, and the way that usually happens on-prem is you call. Even if you have enterprise support, they send a technician out. They give you a 4-hour window. That technician comes. Hopefully, they have that part in the van. If they don't, then they have to go somewhere else, pick it up first, and then they actually have to go through the process of going to your data center, getting in, installing it. It is a very different experience than the 7 minutes that it takes to switch to new hardware. Any other questions? Yes, in the back. Yep. Right. So the question is, if you decide to go through and take that box down on the secondary, if you decide to go and resize that box, if you're running that cost optimized setup, obviously that data is sitting at the disk level. When you resize the box, all of a sudden everything has to be loaded from disk into memory. And it absolutely is dependent upon the size of the database. It also is dependent on whether or not you are running GP2 or provisioned IOPS volumes. So I don't know if we can give a definitive answer.
Is this on? Sorry.
Yep.
So typically when HANA starts up, right, it needs to load the row store before the HDB index server becomes available, right? So once the row store has been loaded, you can see it in the HANA trace logs, right? I'm loading the row store, and it takes maybe minutes to load the row store. Once the row store is loaded, actually you can connect to that instance. The rest of your column store is going to be loaded lazy in the background, right? That's lazy loading. And then if your users are running queries against HANA, right, let's say select star, where, et cetera, it's only going to pick those columns from that query and load those columns into memory, right? So if the question is how long does it take to load 4 terabytes, that's different than how long does it take HANA to become available and usable again, right?
Yeah. So the question is, is the mileage going to vary? And that's absolutely yes. It depends upon your HANA database size. Also depends upon your EBS volumes, GP2 or provisioned IOPS, IO1, because they have different throughput characteristics for those. Yes, in the back. Unfortunately, we don't disclose that type of information to the public. So the question was, what sort of growth are we seeing in AWS? I can answer that I'm very optimistic about the outlook from our team's internal growth perspective, but yeah, we don't release any particular numbers on that. Also cannot answer how many people we have as part of our practice. Any other questions about technology up here? Well, thank you again very much. Really appreciate a very attentive audience, and thanks for playing along.
Thank you.